all. Today we are going to discuss about the various loads acting on a simply supported beam. Okay. First thing, consider a beam of length AB 8 meter. One end is fixed end, another one is roller support. Now there are various types of point loads are happening, but making an angle with respect to horizontal plane. For example, consider a point load 4 kN is acting at 30 degree to horizontal plane. This point is called C. One more point load, it is also acting, making an angle with the horizontal plane 60 degree for 8 kN. Another point load is acting 6 kN, making an angle with horizontal 45 degree. Okay. Now, what are all the reactions are happening here that we want to find out here? So this point is called A. C, this point is called D, here E, end is B. Okay. For roller support, reaction is only RB. For point A, there are two reactions are happening. One is called horizontal reaction, another one is called vertical reaction. So HA as well as here RA, reaction at A. Vertical reaction is also called as reaction at A. For the situation, we want to find out free body diagram as well as resolving the forces into vertical component. Now, extend each and every point the same line. We can able to convert this into free body diagram for the given situation. Now, resolve the forces into vertical component and find out the unknown reactions at A as well as at B, that we want to find out here. This is your horizontal reaction, this is your reaction at A, this is your reaction at B, vertical action. Now we want to find out the vertical component of each and every point load. By resolving the forces horizontal as well as vertical, you consider only vertical. This is called as 4 sin 30, this is called as 8 sin 60, this is called as 6 sin 45 degree. Okay. Now we can able to formulate the equation under equilibrium condition. Forces along upward direction is equal to forces along vertical direction. So summation of forces along y direction is equal to 0. Now the forces acting upward direction, RA plus RB is equal to acting downward direction 4 sin 30 plus 8 sin 60 plus 6 sin 45. Now we can able to formulate the equation by substituting the values. We can get 4 sin 60 is called 2 kN plus 8 sin 60 is called 6.928 kN plus 6 sin 45 is called 4.242. So this is resolving the forces in terms of RA plus RB is equal to what we can able to calculate. Similarly, resolving the forces along vertical direction, summation of forces along x is equal to 0. Now you are resolving the forces along vertical horizontal direction. So sum of the right side forces equal to sum of the left side forces. So sum of the right side forces are HA plus 4 cos 30. This is acting on right side. So the remaining left side forces are is equal to 8 cos 60 plus 6 cos 45. So this is the forces, external forces along x direction is equal to 0. Now the 4 cos 30 value is HA plus 3.464 kilonewton, that is equal to 8 cos 60 is equal to 4 kilonewton plus 6 cos 45 equal to 4.242 kilonewton. From this we can able to formulate horizontal component at A is equal to, by simplifying this we can able to get 4.778 kilonewton. This is the reaction happening on horizontal HA. Similarly, we want to find out reaction at A as well as at B. For this, we want to find out moment about A is equal to 0. So, moment about A is equal to 0. Summation of moment about A is equal to 0. Now, at the point the moment value is 0, now you consider the right side forces. You can able to read it like this: force into perpendicular distance. The distance mentioned here is 2 meter, 2 meter, 2 meter as well as 2 meter. Now, force into perpendicular distance. First force you consider 4 sin 30. 4 sin 30 is here 2. 2 into 2, perpendicular distance is 2. Rotating along clockwise direction, to take it as minus. So next thing, 8 sin 60. 8 sin 60, this is also clockwise, minus. 8 sin 60 value is 6.928 multiplied by perpendicular distance is 4 meter. Here this is called 4 meter clockwise. So 4. Next perpendicular force is 645. 6 sin 45. The value is minus 4.242 multiplied by 2 plus 2 plus 2. Totally 6 meters are there. 6. At last, one vertical reaction at B is there. It rotates in anti-clockwise manner. So take it as positive. Reaction at B into 8 meter. So that is equal to 0. So now we want to simplify this. From this we can able to get reaction at B is equal to 7.1455 kilonewton. This reaction at B value, you substitute in RA plus RB, that is equation number 1, you can able to find out RA value. So RA value. So here by simplifying this we can get RA plus RB is equal to 6 plus 4 10, 10 plus 2 12, 12, that is some 13.242 like this. From this you subtract RA is equal to 13.243 minus 7.145. So what is the value of RA we are getting? RA is equal to 6.0245 kilonewton. Now we found the unknown values of horizontal component of at A, vertical component RA as well as RB. Now we can able to calculate shear force value for this problem, and also we can able to draw the shear force diagram, bending moment value for this problem, and also we can able to draw the bending moment diagram. First thing we want to find out